Today's lesson's on exponential functions. Some definitions that we need to know. An exponential function is a function where the base is a constant and the exponent is a variable. An asymptote is a line that the graph of the function approaches. This means that the graph gets really close to that line but never touches it or crosses. Our parent function is f of x equals b to the x power. If b is greater than 1, we're going to have an exponential growth. If b is between 0 and 1, we're going to have an exponential decay. We need to have 3 points plotted on all our graphs before doing any transformations. You'll see these 3 points here, 0, 1, 1b, and -1, and 1 divided by b. These should be fairly familiar to you from other functions and transformations. If h is positive, we're going to have a horizontal shift left, horizontal shift right if h is negative, vertical shift up if k is positive, vertical shift down if k is negative, reflection over the x-axis if a is negative, vertical stretch if a is greater than 1, and if a is between 0 and 1, we have a vertical shrink. So, let's graph this function, describe the transformation, and state the asymptotes. We have 3 to the x, so I want to plot my 3 points. 0, 1, 1b, so 1, 3. b here is 3. And then our third point is -1, and 1 divided by 3. Here my asymptote is y equals 0. Unless I have a transformation, my asymptote is going to be y equals 0. Let's look here, we have f of x equals 2 to the x power, subtract 3. Let's just graph 2 to the x first. So I'm going to graph my 3 points, 0, 1. b is 2 here, so 1, 2. -1 and 1/2. So right now my asymptote is y equals 0. But we have a transformation here. Go back to your previous slide, and we have subtract 3. That's going to be a vertical shift down 3 units. So I'm going to take these 3 points that I've plotted, move them down 3 units. Also, when I move it down 3 units, I'm moving my asymptote down 3 units. And I should be drawing my asymptote with a dotted line. Asymptote is y equals -3. My description here for the transformation is a vertical shift down 3 units. Right here we have b equals 4. Just going to graph 4 to the x power. 0, 1, 1, 4, -1, 1, 4. Asymptote is still y equals 0. Now, my transformation here is we have subtract 5. So that's going to be a horizontal shift right 5 units. So I'm going to move all my points right 5 units. Does this change the asymptote? No, it does not. So my asymptote is still y equals 0. First thing I'm going to do is just graph 2 to the x power. So my b is 2. So I got 0, 1, 1, 2, negative 1, 1 half. My asymptote is y equals 0. Now I have subtract 3. That's going to be a horizontal shift right 3 units. So I'm going to move all 3 of my points right 3 units. My asymptote is still the same. It hasn't changed. Now I have another transformation plus 4. So I'm going to raise a vertical shift up 4 units. So I'm going to take all 4 of my points and go up 4 units. Will this change my asymptote? Yes, it will. The asymptote also goes up 4 units. So my asymptote now is y equals 4. Have we noticed anything? Whatever we're adding and subtracting on, that's going to be how our asymptote changes. So we have a description here. Our description would be, we had a horizontal shift right 3 units and a vertical shift up 4 units. Now this one looks a little different. We have 1/3 to the x power. Still going to do it the same way. We have 3 points, 0, 1. B is 1/3 here. Other point is 1, and 1 divided by 1/3. If we put that in our calculator, do 1 divided by 1/3, we're going to get it should be negative. Look, negative 1 divided by 1/3. So we're going to get negative 1, 3. And our third point is 1 and our b. So 1, 1/3. Notice here we're going down. Here we have an exponential decay. If we go back to one of our first slides here, we'll see that if b was between 0 and 1, we have an exponential decay. We have no vertical shift here, so our asymptote remains y equals 0. First thing I'm going to do in this one is 1/4 to the x power. B is 1/4. What do we notice here? We're going to have an exponential decay because b is between 0 and 1. So at 1, negative 1, 4, and 1, and 1, 4. 1/4 is smaller than 1/3. Notice as the smaller number I get, the steeper my decay gets. I still have no vertical asymptote yet, I have no vertical shift yet, so my asymptote is y equals 0. But now once we do this transformation plus 2, which is a vertical shift up 2 units, now if I move all 3 points up 2 units, my asymptote will also move up 2 units, which will now put the asymptote as y equals 2. Remember, when graphing this, our graph never touches or crosses that asymptote. It's really close to it. Oh, this one looks different because now I have an A and a B. A is 3, B is 2. No worries here. Let's just graph B to the x power. So 2 to the x power. I'm going to graph my same 3 points, 0, 1, 1b, so 1, 2, and 1, and 1/2. Here we have a growth, exponential growth, because b is greater than 1. I have no transformation yet, so my asymptote's y equals 0. So far we have 0, 1, 1, 2, negative 1, and 1/2. So what is A doing? All I'm doing here is 3 times this. So I'm going to now take and multiply 3 times just my y-coordinate here. So if I multiply 3 times the y-coordinate, I get 0, 3, 1, 6, and negative 1, and 3/2. So I'm going to plot these 3 points. Now, I still haven't had a vertical shift, so my asymptote does not change. Notice here, what does A make the graph do? A's making the graph stretch. So what is my description here? I have a vertical stretch by a factor of 3. My asymptote didn't change, so it's y equals 0. First thing here, we have A is negative 1/2. B is 5. I want to do B to the x power. B to the x power. So 0, 1, 1, 5, and 1, 1/5. 0, 1, 1, 5, negative 1, 1/5. No vertical shift. So asymptote is y equals 0. Now, the next thing that I need to do here would be take care of the subtract 2. This would be a horizontal shift right 2 units. So now I'm going to move these 3 points 2 units to the right. Horizontal shift doesn't change my asymptote. So now my 3 points are 2, 1, 3, 5, and 1, 1/5. Now, what do we do with this A? We take it, multiply it by just my y-coordinate. So 1 times negative 1/2. X-coordinate stays the same. So 5 times negative 0.5, negative 2.5. Negative 0.1. Now I'm going to graph these 3 points. 2, negative 1/2. 3, 2.5. 1. We didn't have a vertical shift, so my asymptote stays y equals 0. Let's look here. What is our transformations? A was negative, so it reflected it over the x-axis. It was also 1/2, so that means we had a vertical shrink by a factor of 1/2, and we had a horizontal shift right 2 units. We have A equals 2, B equals 1/4. Since B is between 0 and 1, we're going to have a decay. First thing I want to do is 1/4 to the x power. 0, 1, 1 1/4, negative 1/4. I'm going to label these so it will help me. My asymptote is y equals 0. We have plus 2 here. So this time we have a horizontal shift left 2 units. So I'm going to move these 3 points left 2 units. My asymptote is not changed. My new points will be negative 2, 1, negative 1, 1/4, negative 3, 4. Now I'm going to take A and multiply by 2. So I'm multiplying the y coordinate by 2. So now I have negative 2, 2. Negative 1, 1/4 times 2 is 1/2, 0.5. Negative 3, 8. I'm going to plot these 3 points now. What do we notice here? We got steeper, so we had a vertical stretch by a factor of 2. I haven't had a vertical shift yet, so my asymptote hasn't moved. But now we have this subtract 3, so now I haven't moved. I'm going to shift my asymptote down 3 units. So that's y equals negative 3. I'm going to shift all these points down 3 units. There's my graph. So let's look at this. We had a horizontal shift left 2 units, a vertical shift down 3 units, and a vertical stretch by a factor of 2. My asymptote is y equals negative 3. Here's some problems for you to try and turn in. And here's some more problems for you to try and turn in.